Hi, it's bench equipment time. What you're looking at are a couple digital multimeters. This is the X-Tech EX330. I did a video about this model probably 4 or 5 years ago, and it was recommended as a good sort of occasional use, weekend warrior kind of multimeter that is reasonably inexpensive, that most people could afford. Street price on it today, probably somewhere around 60 bucks. Which is not bad. It's got a lot of good features, and it's a modern meter that does all the things that a modern meter does. And basically, it's easy to use. It has a big giant display, so it's easy to read the numbers, and it does most of the thinking for you. It's pretty much almost a foolproof device, and it's good for beginners or people that just need to use it occasionally. Then we have sitting next to it, this is my Fluke Model 83. This was actually the very first digital multimeter I ever bought. And that was all the way back in, it was probably 1987, maybe 1988. I don't remember exactly when I bought it, but I remember where I bought it and why I bought it. Up until this, what I was using was a good old-fashioned Simpson Model 260 analog meter, the kind with the needle that sweeps back and forth. And Simpson was always sort of the go-to benchmark meter of the day. It was tried and true. The biggest problem with them, especially when you took them out on service calls out in the field, was they had Bakelite cases. One tumble off the ladder and you're buying another case. And I bought several cases over the years and was kind of tired of doing that. I went to a local supply house where I bought vacuum tubes and some other things like that at that time, and I knew the owner of it, and we were both located in the same city. Kind of knew me, and he would give out my name for people that had NuTone equipment so I could go fix it and that kind of stuff. I went in to see if he had a case for the 260, and he said he was out of stock, but they had just started carrying the Fluke brand multimeters, and he said, let me show you, because these things are really great. Now, this is not the first digital Fluke multimeter ever made. I think they actually began making them sometime in the late 70s or early 80s, but they were expensive and I wasn't in business yet, so why would I have one? So he showed me this. This is the Fluke 83, and I don't remember exactly how much I paid for it, but I want to say it was close to $300. It might have been around $280 or so. It was a lot of money in say 1988 to spend on something like this, but he assured me that it would be well worth the money and it would pay for itself over time if for no other reason I wouldn't have to buy any more Bakelite cases. Now, this multimeter has gone out with me on service calls, I don't know, maybe 1 million times. It's been dropped and banged, and it's got its traditional yellow Fluke shock absorbing holster on it, and it's actually been repaired a couple times. I've replaced the screen on it once because this is an early one. This is a Fluke 83, the original one. They still make 83s today, but now they're 83Vs or 83.5s because they've been updated a lot over the years. But this is an original one. The displays on these tend to at least on these original ones, they tend to fade out. It's an LCD display. So we can go ahead and turn this on here. No backlight, nothing like that. Didn't have that in those days. So I replaced the screen once. These little rubber buttons here, the markings on them wear off, and I've replaced those before. I've also replaced either 2 or all 4 of the input jacks. I don't remember exactly. Sometimes when you have leads plugged into it and it tumbles off the ladder or out of your tool pouch and you grab it by the leads, it pulls on the input jacks and they break, and then you got to replace them. It's one of the nice things about buying a name brand like Fluke is that parts are available for it all over the place and none of it is terribly expensive. Also, it did go in once for calibration. I think that was at the time when I was having a problem with the display, and I took it to the local Fluke service center to see what was up with it. They were only like 20 minutes away from where my shop was, so that was easy. And the guy looked at it and said, well, leave it and you can pick it back up tomorrow. We'll pop a new screen into it for you. We won't charge any labor just for the cost of the screen, and we'll quickly check the calibration. And then I got a calibration sticker, and that's all good. I remember when I got the Fluke, making the changeover from an analog meter to a digital multimeter was actually quite an upgrade and quite a change. It required a different type of thinking and different patterns in how you use the multimeter, because a lot of times on an analog meter, when you're measuring things, you're measuring continuity or you're measuring resistance or voltage, you're sometimes not reading the actual values on the meter. You're actually watching more for the swing of the needle. And after years and years of using it, you get to know if it swings up this far, yeah, you're close. It's pretty good. It's pretty much spot on to where you want it to be. It's not about the absolute number. It's more about the range that the needle lands in. Now, for some of you who follow along on a lot of my videos, you may know or remember or have seen that I'm putting together a second workbench. It's going to be for RF alignment. RF is radio frequency alignments for things like tuners, and it's going to be a dedicated workbench, and it's going to have more old school equipment on it. So far, I've bought some AC power supplies. I've bought old school analog oscilloscope, and I'm in search of other pieces of equipment that I need to do this. This is going to be a dedicated workbench only for RF alignments. One of the things I want for it is I want a different kind of meter. And so we're going to go back to where we first began, and I've been looking for and have finally found an analog bench meter that I like. And here it is. This is my BK Precision Dynascan model 177 vacuum tube voltmeter. And this is very similar, although way nicer than the Simpson that I had, because the Simpson could be a bench meter, but it was really more of a portable meter. And while this could be a portable meter, in my opinion, it's more of a bench multimeter. Why did I buy this one in particular? Well, I bought it for several different reasons. The primary decision was based on the size of the actual meter movement itself. This is a 4-inch by 6-inch meter movement. It has really easy to read large legible numbers. If it's sitting on the workbench 18 inches or 2 feet away from me up on a shelf, you can easily glance over and see it, and it won't be hard to read at all. The other decisions about buying a meter like this were, one, it's made by BK Precision. Now, BK Precision is a company that still exists. I think nowadays they're in Canada, but when this was made, they were in Illinois. They make good mid-level quality equipment. It's not super high-end stuff. We're not talking about Tektronix or Hewlett-Packard here, but we're not also talking about those no-name brands that you find at Harbor Freight. This is a good level, could be considered a hobbyist, but also could be for professional, and it meets all of the requirements that I have for this type of meter. The other decision was to buy a vacuum tube voltmeter instead of a FET voltmeter. Voltmeters are later designs than a vacuum tube voltmeter, and the advantage of a vacuum tube voltmeter is the super high impedance of the probes when you connect it to a circuit. What that means is that connecting the meter to a circuit to measure something won't affect the circuit in any meaningful way, so you're getting truer measurement. There are some compromises that you have to make, because while, like I said, if you have a digital multimeter like this, it does most of the thinking for you. As long as you set it on the right setting, you're going to pretty much be okay. These are often referred to as auto ranging meters. So if you're measuring voltage, it's going to figure out what scale it should be on and change it over automatically. And there's all kinds of protection built into it. So unless you do something really bonehead with it, you're not going to blow it up. This is completely different. The way I was taught back in school was this is a thinking man's meter. You have to understand not only how the meter works, but also how to use the meter correctly, because you get to make all the choices as to how it's set up for the task that you're going to be using it for. Also, because it has a vacuum tube inside of it, it has a warm-up time. You have to turn it on ahead of time and let it warm up. Now, it doesn't take very long. However, if you want your readings to be as accurate as possible for a meter of this type, and we'll talk about accuracy in a minute, you should turn it on well ahead of the time you're actually going to use it and leave it turned on, because the vacuum tube is going to generate heat inside the metal case, and that heat will affect other components in here. And what you really want to have happen is have it leave turned on long enough, maybe 20 or 30 minutes, so everything, all the temperatures inside the case are equalized and it won't drift as it warms up more and more, and you certainly don't want to be turning it off and on and off and on and off and on, because that's just annoying. So a meter like this can measure AC voltage, DC voltages, both plus and minus, and ohms or resistance. It cannot do current measurements. It's not designed for that. And it's not an auto scaling meter. You have to choose your range based on what you're measuring and what you anticipate that measurement to be. So there are multipliers for resistance, because the range of the actual meter itself, the movement, it's limited from here to here, so it doesn't go around and around and around. So it uses multipliers to keep the needle within the range of the actual scale itself. And when you use a meter like this, regardless of whether you're doing voltage or resistance measurements, you want to try to set up your ranges here to keep the needle sort of in the middle third of it. You don't want to be way down here, and you don't want to be way up here. You want to be kind of in the middle range, because this is where it's the most accurate. While we're talking about accuracy, let's talk about accuracy of each and every meter I showed you. So here's our X-Tech EX330. This has an accuracy of 0.5%, so it's 1/2 of 1% accurate. Our old school and original Fluke 83, this has an accuracy of 0.1%. So it's 5 times more accurate than the EX330. Our B&K Precision 177, it has an accuracy of 5%, not 0.5%, just 5%. It's 10 times less accurate than this. However, a meter like this, I didn't buy it for its actual accuracy. I bought it because I need something that has a visual indication when I'm making adjustments on tuners, and I'll get to that part again in a minute. Once you've chosen your vacuum tube voltmeter, you need something to hook up to it so you can actually make measurements. That would be the probes. Now, this particular one came with an actual original probe, just like it came with when it was brand new. However, these are not standard probes. These are old school probes. This particular meter, as near as I can gather from having poked around inside of it, this was made probably sometime in the late 1970s. Could be as early as 75. It's hard to know exactly. And this is a model that B&K made for a really long period of time, and there's actually several different versions of it. This happens to be one of the last versions that they made before it was discontinued. And one of the ways you can know that, just as an aside, is that if you look inside the chassis, which we'll get to in a minute, you'll see that there are actually 2 spots for 2 vacuum tubes. However, this one only has a single vacuum tube, and that's how you know it's a later one, because they updated it and made a change over time. Anyway, back to the probes. So this requires old school probes, and I'm not really going to live with a dodgy old probe where the wire is really stiff and the probe itself is probably somewhat questionable or possibly blown up. So I didn't want to do that. Modern probes like these are the ones that fit my Fluke. As you can see, they plug in here like this. These are basically shielded banana jacks. So there's a banana plug inside where it's really hard to see the shiny bit, and it has this plastic shield to cover it up. So these are shielded banana jacks. That's what most meters use nowadays. Some meters will have unshielded banana jacks, and where you can see the metal ends, and I don't really have an example of that. Oh, this is similar. This is not exactly that, but it's similar. So this is a sort of a universal plug with banana jacks. This could be for a multimeter. In fact, I believe that this actually would fit in the Fluke if we wanted to use it that way. So these are unshielded banana jacks. Don't see that much on meters anymore, new ones, because I think it's a liability thing, gotta watch out for everybody's safety. This uses a different kind of connector. This is actually a connector. It was made by a company called Switchcraft. Switchcraft is still in business, and oddly enough, they made switches and connectors. What are the chances? So this is actually a Switchcraft. It's a microphone connection jack, like a microphone with a cord that the MC uses at the wedding. That's the kind of jacks they had in the 70s, and that's what you need. And on the end of the original probe is its other half. it's the female microphone jack, and it screws in. And you might think, well, that's kind of weird, because why would they use something like that? But actually, if you think about it, it's not a bad choice, because if this were used, if this was a microphone and it was plugged into an amplifier or something like that, or connected to an amplifier, I should say, you certainly wouldn't want a dodgy, loose connection on your microphone, because if it wiggled around, you get a lot of static, and then the bride's going to get mad and you're not going to get paid. So it's not a bad choice. While I was looking for this, I also was looking around to see what kind of probes I could find for it, because, you know, meters without probes aren't going to do you a lot of good. And what I found was a company online, and the company is called Kentcraft LLC, and they're located in Marietta, Georgia. And I've actually been to Marietta, Georgia, because now that we're in Tennessee, it's really not that far away. And this fella that makes these, I bought some probes from him, brand new. He makes these up himself. He has a nice little business. He makes up all different kinds of vintage probes and connectors and other things like that. I went ahead and bought some. Now, his are a modern day take on what came with it originally. And yes, there are 2 packages, and we'll get to that in just a second, if I can get this one opened up. Because when you bought one of these, it came with the standard probe, but there were also optional probes that you could get for specialized use. And I decided, since we're going to be doing this, we might as well just buy everything. So this is the set that he makes up as the general purpose set. And he does a very nice job with these. He puts the little Velcro strap on it so you can wind them back up. And he uses good quality parts, good quality probe ends. These are made by Fillmore, which is sort of your go-to company for little bits and odds and ends like probes and alligator clips and things like that. It has the probe tips with the threaded portion right here, so you can like screw banana jacks to it or something like that. You can actually take off the end. I'm not going to get it off now, but you can if you need to. So these are good quality probes, not super sharp, but that's all right. Good quality wire, not silicone, but still good, with the Switchcraft connector on the end. These are brand new because they still make these. And then what he's done is, this is the ground cable, and that does have a silicone wire on it. So what he did here was build a modern take on an old school probe. So the original probe, like this, it has a little switch on it right here, and you change it from one position to the other based on what you're measuring. What he did, and this would be a complicated thing to reproduce in today's world, so what he did was, he has one jack, which we're going to go ahead and put on here. It's always fun to do this when you, with your left hand, when you're right-handed. All right, and then, oops, we'll plug our ground into the ground socket down below it. And you might have noticed that when we connected up the probes, the needle moved. Why did that happen? Well, it happened because we connected something to the meter and it's sensitive enough to see the change. Instead of having one probe with a switch, we now have 2 probes with different uses. And no, you don't use them together like this. You use one or the other with the ground. So this is the DC probe for resistance, and this is the AC probe. And then you have the ground. It's not difficult to use them like this, and I think it's a good way to do it. One of the things I might do is add a little bit of heat shrink tubing to pair up some of these maybe halfway down so they're not flopping around so much. But other than that, it's very good. So this is that set that he sells. And then he also makes the optional RF frequency probe, which is this one. And this has the ground clip and the single wire, and it all goes into the Switchcraft connector. And that one is for measuring RF signals on this, which it can do. And this is that set. And now these are not super expensive. I think both of these together with the shipping were about $60, which is a good price. It may have been a little less than that. I don't remember exactly, but they were a reasonable price. And also, it's not like there's a lot of choices. If you want something, you know, especially if you want something made individually by someone locally, it's a good way to go. I'm not going to give you a full-on step-by-step on how you use a vacuum tube voltmeter, but I am going to sort of take you through one basic use of it to measure some resistance. So what we're going to measure is, we're going to measure this. This is a 50 ohm resistor, and this is a pretty good resistor. It's a 2% resistor, so it's 50 ohms plus or minus 2%, which is pretty good. These are used in LA52 door chimes. Right now our needle is sort of 3/4 of the way up the scale because we hooked the probes to it. So what we have to do is we have to sort of zero out the adjustments on it to make sure that it will read accurately. So the first thing you do is you take your ground alligator clip and you take your black probe, because that's for measuring resistance, and you clip them together. And the needle goes all the way to the left. Now we have two adjustments here. We have one down here that says 0 and one over here that says ohms. So what we want to do first is zero out the meter. We want to turn the adjustment until the needle is just on the 0. One of the nice things about meters, something if you're considering getting one of these, one of the things to look for is you can see below the 3rd scale is the shiny arc. That's actually a mirrored portion of the meter face. It allows you to read it more accurately. It reduces what's called the parallax effect, which you get on mechanical meter movements. It makes it easier to read. Anyway, that's just an aside. So if you find a better quality meter, you'll have that on it. So we'll zero this out just like that. And now we're going to take the alligator clip and the probe apart like that, and the meter swings all the way back here. And what we want to do is use the ohms adjustment, and we want to set the needle right on infinity. And infinity is the last hash mark on the top scale, like that. Now our meter is ready for use. So all we have to do is we'll take our 50 ohm resistor, we'll clip the alligator clip on one lead, and we'll take our probe and touch it to the other lead, and the needle swings over, and it's just very slightly higher than the 5 on the top scale. But what you have to remember is this, the range knob down here for measuring resistance is, it's R times 10. So whatever the reading here is, 5 times 10, which is 50. And if you figure plus or minus 2% and taking into account the 5% accuracy, my 2% resistor is pretty much spot on. It's right where you need it to be. If we change our range knob here to R times 100, you'll see that the needle is going to drop way down. It's going to end up somewhere right down in there, halfway between 0 and 1, which would be 0.5. So it's 0.5 times 100, that gives you 50. If we go back up to times 10, now we're just right on the 5. And we'll talk about why that could be the case. And if we go down here, it's R times 1, no multiplier. So our needle is going to jump all the way up here to 50. Again, you want to try to keep your needle in the middle of the range if at all possible, because that's where it tends to be the most accurate. So that's basically what you need to do. Now, when we moved the range switch and things moved around a little bit and we went to the times 100 scale, went up here, and then back to the times 10 scale, it didn't quite go above the 5 like it originally was. It sort of settled in on the 5. So why would that be the case? Well, a couple different things. One, nothing's been done to this. This is how it came out of the box. So the switches all need to be cleaned, and maybe a little bit of work needs to be done inside. But we'll get to that in just a minute. So I'm going to set this up a different way and show you why I really bought this. So let me explain to you why I bought this more than any other reason. When you do radio tuner alignments, there's lots of little adjustments inside the tuner itself to adjust and align the frequencies that go through the different stages of the tuner. So the little tiny signal that comes in from the antenna has to be adjusted, and the tuner has to be tuned or aligned to process the signal correctly and make it either as strong as it needs to be or as weak as it needs to be, depending on what you're doing exactly. So what you're doing is often referred to as you're either peaking up a signal or you're nulling out a signal. Peaking is setting it at its highest possible level, and nulling it is setting it to its lowest possible level, or sometimes you'll be somewhere in between those. On a meter like this, it makes it a lot easier to see. I have sort of an example set up down here on the workbench that you can't see. I'm going to connect the meter to my little working example to show you how that goes. So right now we're on infinity, which is where we want to be. I'm going to connect the meter to the circuit. And right now we're reading about 1/2 of an ohm. Now let's say we're working on aligning a tuner, and the instructions for the step says, for that step of alignment, says you want to peak the signal where it's connected at the moment to its highest possible point. So what you do is you take your little plastic tuning tool and you insert it in the little tuning slug where you're going to go to try to adjust it. As you do that, the needle is going to move. And as you tune it, the needle goes up and up and up and up. And as you pass the midpoint, the peak, and you start going too far, then the needle starts to go down. But it doesn't go back down to the left because it's moving in an arc. So the signal is strongest right in the middle, right there. That's the strongest that you can get it because it's at the top of the arc. And if you go too far one way, it drops down. And if you go too far the other way, it drops down. So what you want is you want to peak the signal right at the top of the scale, which is about 10. And you go back and forth until you get it spot on. There are some tuners that you may have to peak up 6, 7, 8 adjustments as you go through it, and then sometimes based on its design you have to go back to the beginning and then fine tune it and then go through it again and then fine tune it and go through it again to get everything as close to spot on as you possibly can. When you're doing this, when you're peaking a signal, it's much easier to see the results of your adjustment by the swing of the needle on the meter face than it is trying to watch numbers on a digital multimeter, because the numbers on the digital multimeter could go, depends on the meter and how you have it set up. It can read positive numbers, it could read negative numbers. It's all numbers changing, and the numbers on these change really fast, so it's hard to see. Whereas the needle movement is more gentle and even, so it's easier to see. Basically what it comes down to is, for analog tuner alignment, you need analog meters, because the number, the absolute value of it doesn't matter. It doesn't matter whether it's 10 or 11 or 9. What matters is that it's at its highest possible point. So it's not the actual number that matters, it's where it is on the scale. Same thing is true when you null out a signal. You want to null it out to its lowest possible setting, like that. That's as low as it will go. And you've nulled it out. It's not quite 0, but it doesn't necessarily have to be. And maybe when you go back through the steps the second time, it may be a little bit lower. So that's why this is beneficial, because it makes doing the alignment easier because you're watching the swing of the needle. That's the thing that when I bought my Fluke 83, when I bought this, I had to relearn how to use the meter, because I was always used to looking at the swing of the needle, not the numbers that it was pointing at, because you get used to doing it that way. So now I have to kind of relearn a little bit how to do that. So that was the reason I bought this in the first place, and that's why I bought a big one like this, because it can sit up on the shelf and it'll be easy to see. So we talked a little bit about what's inside the meter, and I like to show you that. And through the magic of having two, I can show you the inside of one without taking the first one apart, because yes, I bought 2 of them. This is sort of a matched pair. They didn't come from the same place. They came from different sellers on eBay, but they are exactly the same model. They have everything about them is exactly the same, and they're both fully functional. However, because of their age, they probably could use a little sprucing up. So this is the inside of our 177 vacuum tube voltmeter. So here's our one vacuum tube right here. This is the back of the meter movement. There's a power transformer down here. And then down here in the dark areas, you have your selector switches and your two adjustment pots. So there's not a whole ton in here, but it's made well. So what kind of things need to be done? The switches, the contacts on the rotary switches here, and this has several different layers to it, and this one down here the same way, they just need to be cleaned up because the contacts are oxidized and dirty. They're not really bad, but if I'm going to do a little bit of work on it, I'm certainly going to clean it up. And just as a point of interest, these are the same type of switches in a slightly different configuration than what NuTone used in model N2561, 2562 intercom systems, because it was sort of the go-to switch of the day, and that's what it has. And then there's a couple adjustment pots down here that just need to be cleaned a little bit. There are a few capacitors that should be changed, and I think you can see one here, and there's one up here in the top. And I think there's one other one that's kind of buried down inside. Those will get changed out just because of their age. They're probably okay. The thing about equipment like this is if they see a lot of use, it can rack up into the thousands of hours, but it's not the kind of device that's left on 24/7, so it probably doesn't have hundreds of thousands of hours, but it makes sense to do that. So clean the switches, replace a couple capacitors. These three adjustments here, here, and here, these are alignment adjustments that you measure with a multimeter and then set things up correctly so it reads accurately. And then you have your one vacuum tube here. Those will both be checked, but odds are these are not in a high stress application, so they'll probably be just fine. This is a 12AU7. This is a twin plate triode tube, and its purpose, this is used entirely to drive the meter movement here. And the way this works is, as you saw in the last section, we have our zero adjustment and our ohms adjustment. So a twin triode tube, the way you look at it is, there are two sections of the tube, plate number one, plate number two. And when you want to zero out your resistance, when you adjust this control down here to get the needle to stop on 0, there's a balance between the two plates. If this vacuum tube has 2 volts on it and this vacuum tube has 2.5 volts on it, the needle, it's out of balance. You need a balance. You need 2 volts and 2 volts at the same time, so the needle will go to 0. If it's 2 and 2.5, the needle's either going to read high or the needle's going to read low, and you want it right on 0. So this adjustment here balances out the voltage between the two sections or the two plates to achieve 2 volts and 2 volts, so the needle rests on 0. And that's basically all that it does. It's a nice design. It's a very simple design. It's how most vacuum tube voltmeters work. The other thing that's nice about these, there was another consideration, is some vacuum tube voltmeters are not line cord powered like this. This has a power transformer in it. They'll use either a D cell battery or 2 C cell batteries sometimes, and the batteries are to drive the part of the meters to measure voltage and things like that. I didn't want that because I don't have to deal with the batteries, and since these are going to be bench multimeters, it's easier just to plug them in. So these are well made. It's an all metal case, including the back, and when I'm done with this, this will go back on here like this. Oops, wrong way around, this way, like this, screws onto the back. See, they even give you holes in the back for the alignment, so you don't have to take the cover off to do that. You have some ventilation holes here for a little convection cooling, let the heat out from the vacuum tube. It's just a well-made piece of equipment. It also has a really nice tilting handle, which you can swing forward or backward, so it can lean back to make it easier to read, and it's not going to fall over when you work the knobs and things like that. So there you have it, a pair of BK Precision Model 177 vacuum tube voltmeters. I did buy 2 sets of probes one for each unit, so they can be set up and left there all the time. And the other nice thing about doing that is you could do, you could do voltage and ohms on one and frequency on the other, or however you want to set it up. It's fine, but you really should have one set of probes for each meter and not have to switch back and forth. Oh, the other thing I was going to show you before we're done is, so here's our one vacuum tube right here, and as you can see right here, there's a hole in the chassis. See, your finger goes in the hole. This is where another vacuum tube used to live. So on the early versions of these, this was a rectifier tube. It turned AC into DC to run the circuitry. In the later models like these, they did away with the rectifier tube and they have diodes instead, because that's more efficient and more cost effective and probably less costly to manufacture. So the later ones are a little more modern than the early ones were, but these are well-made, long-lasting devices, and if you take care of them, they'll probably last your lifetime. So that's it. So if you're looking for a vacuum tube voltmeter, these are a really good choice in my opinion. Check out the Kentcraft LLC website in case you need vintage probes. He seems like a good guy. He seems to care about what he does. And when you buy probes, he gives you free pens. And what's better than that? We all like free pens, don't we? I hope you found this interesting, and maybe for someone it will be helpful. If it is, give it a thumbs up on YouTube, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.